All right, I think we're almost ready to get started here. Thanks everyone for coming today. My name is Ben Rakers with Eurotherm. We're part of Schneider Electric. As Eurotherm part of Schneider Electric, we focus on the industrial control side of thing, so mostly PID discrete controls. With that has come a lot more security initiatives, both from Schneider Electric and also just general best practices that come with the industry. I'll take about the next 20 minutes or so to go over some of that, and also talk about some new product we have that implements these new security practices. Firstly, I'll start off with industrial connectivity and security. How do your devices communicate? Everyone's got their own devices, whether it's Modbus, Backnet, Ethernet IP, all of that. They all have to talk together, get that data, and bring it to a central source. So how do my devices communicate? So Backnet, Modbus, Ethernet IP, etc. Start off with Modbus. That was brought in by Schneider Electric around 1979. It's kind of the standard communications protocol today. More or less, most of your devices you see in the field will have some sort of Modbus communication, whether that's at the base level or going out to a field device. All of ours communicate amongst itself over Modbus, and then we've got other add-on protocols after that, whether it's Modbus, Backnet, Ethernet IP, PROFINET, PROFIBUS. All of those can be added on in addition to Modbus. Personally, we always have Modbus in our devices, though. Ethernet IP is the kind of Allen Bradley standard. It's managed by the ODVA compliance group. DeviceNet is very similar to that, not identical, but they are very, very similar in the way they function. They're based more off input-output tables, whereas Modbus is based on registers for each device or for each parameter. So your set point, PV, output, PID status, all that is given an address in Modbus. Ethernet IP, you assign that to a table, put it into that table, and the devices communicate based on those tables. They talk back and forth. PROFINET, I refer to some of my notes here, bear with me. PROFINET and PROFIBUS, both very similar. Kind of layers on top of your standard analog signal, so your 420 milliamp. It's a communications protocol added on top of those, so less wiring, less field installation, a little bit cost savings. BACnet, most people probably know BACnet if you're at this show. BACnet was developed by the ASHRAE organization. It's kind of the de facto in this industry, whether it's your thermostat on your wall, your PID controller, your PLC, HMIs, all of that. In this industry, BACnet has kind of been made the standard that's used. A lot of companies will make gateways. If you have a Modbus device, you need to communicate on BACnet, or Ethernet IP, you need to bring that into a BACnet system like a Schneider Electric EcoStructure, Johnson Controls Metasys, any system like that that's looking at a whole building automation is most of the time a BACnet system. And there are many more protocols. Some devices have their own custom built that they've written that they use, and then you got to kind of decode what they've done to get all the info out. Mostly I'll focus on BACnet in this just because that's the standard in this industry. This is a typical Backnet diagram. At the bottom, you've got your connected devices. So I've shown our EPC 3000 controller on a steam PRV station, so pressure reducing valve, and a hot water heat exchanger. The blue line is one communications protocol, green is another, gray is another. So you can see we're going from, let's say, Modbus at the bottom up to Backnet and that Nanotech, and then Nanotech is communicating up to building automation system, Schneider Electric EcoStructure system that then an operator can stand at their, one station and see what's going on for the whole plant, rather than having a guy walk around with a clipboard, write down what the pressure is on boiler 1, boiler 2, boiler 3. He can look at one screen, see everything that's going on at once, and save time, money, efficiency, all that. Why is that important? So everyone wants to have more data. Everything's about data, whether it's real-time data, historical data, trending, however you want to get that data, everyone wants as much as they can get. So having your connected products communicate all the way up through, whether it's an RTD reading the temperature, the boiler level, boiler pressure, steam pressure, and steam header, whatnot. Take that up to your edge control devices. The edge control is going to be like our Nanotech product, our EPC 3004. That's actually collecting the data and then serving it up to your building automation system, where you're collecting that data in a BACnet system to then feed it on to maybe your finance department to see, okay, we've used X amount of energy for the month, for billing, whatever you're going to then use that data for later on. Like I said, they're going to infrastructure, building, data center, however you're utilizing that data after the fact. This is just a good diagram of how devices talk. So you can see the yellow line is a Modbus device. The purplish red is a BACnet. blue is LAN, and green is Ethernet. So natively, none of the devices on a yellow line will talk to a device on the blue line or a green line. They have to have the same color. You have to translate that data from one language to another. It's like a language translator if you go to a foreign country. Getting that data together is the key part. So, like I said in the beginning, each manufacturer kind of has their protocol. Modbus is, developed by Schneider Electric. Allen Bradley was Ethernet IP. Siemens was PROFINET, PROFIBUS. So bringing all that together is the key. So you can see at the top level, there's devices that are converting all those protocols so they talk together and keep all that data going back and forth pretty well. So now that you have all your devices connected, the next important thing is security. You don't want anyone getting that data that's not supposed to, or introducing false data, bad data. You want to make sure that's a secure process. So the next most important thing is IoT security. Everyone has their connected devices, whether it's over Ethernet, serial, whatnot. You got to make sure that's secure. So IoT security is detection of network attacks, prevention, notification, and preventing the loss of data, and keeping your system operating. I'll go through a few examples of attacks in the past that you may or may not have heard of, where these have been not utilized to their full potential. But essentially what we want to do is make sure you don't have a loss of data, loss of your process, loss of product, which costs you time and money. So why do you need network security? So there's a high cost to having a cyber attack. So the total cost of your average cyber attack is about $1.1 million, increased about 50% from 2018 to 2019. And every year it costs the U.S. economy, or the global economy, between $57 and $109 billion. So you can see not only is it costing you money, in protecting against those attacks, antivirus software, an IT department that implements that, but also you have an attack, your data gets out, your customers are, now their data's out there, they could be losing their credit card information or their secure process information and whatnot. And also your brand. Once you have that breach of security, people are going to remember that when you go to do business with them in the future. You've got that reputation of, we had a cyber attack and we lost X amount of data from these customers. So preventing that is really key. Making sure you never have that on your reputation and keeping your process secure. Whether you're a manufacturer, end user, it's important for everyone to have a good idea on. Examples of some IoT attacks. Some of these you may have heard of, some of them may not. First one is going to be the German Steelworkers attack in 2010. It was a denial of service attack. And essentially what that is either an individual or a group. They target an IP address or an IP network. They flood it with data packets until it's so overwhelmed it just shuts down, is non-responsive, slows down too much to be responsive. It can either be a single person attacking one IP address repeatedly, or you can be a group of computers or simulated devices attacking that IP address. It's common, you'll see it amongst online influencers, stuff like that. If they have someone that doesn't like them, they'll attack their server with something like that to slow them down. It costs them money, and people get satisfaction out of it for some reason. So this particular one, in the German Steelworkers attack, there was a denial of service attack. They overwhelmed the network. Steelworkers weren't able to shut down the blast furnace properly. Steel hardened in the furnace, ruined the furnace. They had to completely rebuild it. So it cost millions of dollars. One that people are probably a little bit more familiar with is Stuxnet in 2010. That was the one that targeted Siemens PLCs and the Step 7 software. More or less what this was, it was a bug that sat dormant for years. It was originally supposedly developed by intelligence agencies to slow down Iran's nuclear production. And the chart on the left there shows the number of infected devices based on country. So you can see Iran's at the top. Obviously, that was the main target of the attack. But it was introduced, the way it's been tracked, supposedly, it was on a thumb drive. Hundreds, if not thousands, of devices might have been infected with it. Some of your devices may have been infected with it, but it stayed dormant until it saw a process that was involved in uranium enrichment. So as soon as it saw that process being performed, it then went active, simulated on the HMI side of things that everything was fine, everything was good. As soon as they actually got to that process, though, it was wreaking havoc, spinning up centrifuges faster than they were designed to go, but the operators thought everything was going fine. It's a pretty interesting one to follow. There's been a lot of movies, books, and stuff made about that one. If you're interested in that at all, want to do any research, there's a few good ones out there. So how do you stop these attacks? There are multiple ways to stop it. Achilles CRT Level 1 certification is something that we have at Eurotherm through Schneider Electric. So what this does is it's a monitor for DDoS attacks, more or less. So if it sees an inrush of packets, data packets flooding the device, it's going to shut down those communications ports and just operate locally. That way you're not getting that false data at your operator interface. If anything, you're going to get no data. Go see what's going on. Connect to the device. You'll see you've got this error or this alarm, and then you'll know, okay, something's going on. We have to correct this. In addition to that, standard networking best practices, managing connected devices and IP addresses. We've probably all dealt with an IT department that's, you want to put a device on the network, you go to them and say, I need an assigned IP address. And it's, jump through hoops. Why do you need the IP address? What are you going to do with it? What's connected? Where's the data going to go? So managing all that, in general, having a best practice is the best way to go. Having firewalls as well as, air breaks where there's, maybe your industrial side isn't connected to your front office side of things. That's a really good way to go as well. But know the vulnerabilities because, with Stuxnet, they did not have that connected to anything. It was a localized system, but it was still attacked through just a worker plugging in a thumb drive or his phone to charge during the day. So use of products with that Achilles CRT certification. So we've got our EPC 3000 controller and our EPC 2000 controller. Those are both Achilles CRT Level 1 certified. And again, that's going to block off that communications port if it does detect an attack. In addition to that, we have our Nanotech product, which has what's called a broadcast storm detection. Different than Achilles CRT, this is going to notify you of that attack. Not going to shut down the communications port, but you'll get an alert that this IP address is being flooded with data. I actually have seen that one in use. When I was in our tech support department, a guy called in one day with a Nanotech. He was getting set point programmer not running properly. I had him unplug his Ethernet connection, worked perfectly fine, plugged it back in, things went haywire. Had him check the messages, and sure enough, there was the broadcast storm detection going off. So there's something on his network, whether it was malicious or not. It could have been a printer that had the same IP address. So someone tried to print, sending that data to the controller. Could be something like that, but it could have also been something, malicious intent. The other thing to note is, although many companies have initiatives, such as Schneider Electric with Achilles, states and governments are also starting to make mandations. California just passed Senate Bill 327, which requires any connected device that has an IP address to have unique security. So when you first power up that device, rather than having the default password 1234, you have to actually set a password before you can go any further. That was passed in California recently and will likely be implemented in many other states to come. So Eurotherm, I want to talk about briefly our new product. I know this is the new product seminar. It's kind of why we're all here is to hear about new products. What we've done is taken our EPC 3000 product that has this Achilles CRT Level 1 certification, as well as Backnet, standard communications, Modbus TCP, and Modbus RS485, and we've put that in a standard control panel. So this is going to be for those applications where you need a process control, also data recording. We have an option with our Nanotech. You need that, but you also need it in a panel. Maybe you don't want to go to a UL508 panel shop. That's going to take a few weeks to get a panel built for you, or you might not have the budget for that. So you can get this. We have them in stock. We're available to ship them right away. It's going to carry all that same Achilles CRT and the communications protocol I talked about earlier. And it's going to be available to you, same day, next day, whatever speed you need it. We'll have them in stock to ship immediately. It's more or less universal. You can use it for pressure, level, flow, temperature, however you need to use it, it'll be available for you in your process. You're more than welcome to come by our booth. We're at 461, booth 461. We can give you a demo of it, take a look. We've got both a version with the EPC 3004 there, as well as our Nanotech in that upper left corner there. It's a dual loop controller with data recording that's going to give you secure encrypted files so that if you're doing like a BTU metering or something like that, you can actually bill the proper amount to your customer at the end. I think I'm a little bit under on time here. We've got a few minutes left. Save some time for questions. Oh, and one more thing, some resources for other best practices for cybersecurity. Schneider Electric white papers, there's quite a library of those up there on the Schneider website, as well as I've worked with guys at RTA one of them in the crowd, and John Rinaldi quite a bit in the past, and they are, I would say, experts on this stuff. They can take care of any needs you have. And I'm glad to answer any questions either now, or if you want to come by our booth, I'll be there the rest of today, all of tomorrow, and be glad to take care of you. Any questions? I don't have any Yeti mugs to give away, unfortunately. I think we've got some coffee mugs in our booth, but no Yeti.
What is that one metering, energy metering device?
Top one there? So that's our Nanotech. It's a 2-loop PID controller as well as secure data recording. So when it's running, it's going to record whatever inputs are connected to it, whether it's flow, pressure, temperature, whatnot, to a secure file that can't be tampered with. We have proprietary software to open it with, free. There's no charge for it. But it could be used on any process. A common one is BTU metering for like energy use in a high rise or something like that, where they charge per floor from a central steam location. Yeah.
The old timey way was measured condensate water, stink.
Oh yeah. Yeah, so a little bit different than that. Hopefully save you a little bit of time and not have someone have to go out there as often, because you can record that, pull the data, as often as you'd like, and be good to go.
But you can do that with chill water or hot water either one.
Yeah, so commonly we'll take like a pressure, temperature, and flow input, and use that to calculate the BTUs.
Right.
Yeah. Yeah, exactly. Yeah, mass flow. If you could do it still based on the condensate return, but a few different ways to do things. Yeah.
I just wonder if it could really be used to also help offset, whatever control that you're probably metering a valve or something like this.
Right.
Obviously, it can't go beyond really much more than that in terms of interfacing with the chiller or the boiler or anything like that.
So it could actually interface with the boiler as well, controlling the level of feed tank, de-aerator or something like that. It has 2 loops of PID control in it. So you could control the boiler level, control the hot water outlet temperature, and record all of that as well. It'll record up to about 30 channels. It's got 8 inputs locally, and then 30 additional over Modbus master communications.
And that you got a website for this link?
Yeah, at the end here I've got, I think, there's my information if you want to call me, and then my email. But we can be found at Eurotherm.com, and then there's a whole section with our products in there. If you come by the booth, we can get you a product selection guide that'll walk you through everything we have to offer as well. Anyone else have any questions?
How does your Achilles certification compare to the UL cybersecurity stuff they're starting to work on now?
I don't know a lot about the UL cybersecurity. I know it's kind of coming. I think it was kind of a directive from where Achilles started. GE owns Achilles. It started off as independent, and then GE bought it. I think it was, the little bit I know about that one, I think it was more of a directive based on Achilles, because we were always kind of told Achilles was going to eventually become a UL certification. There's different levels of Achilles. There's like level 1, level 2, level 3. Level 1 is going to monitor and then cut off those communications. All the way up to level 3 is going to notify, alert, all sorts of stuff. It also depends on the type of device. So if you've got like an Ethernet switch, you might not be able to get level 1 certification on that. You might have to get level 3 just because they've got so many devices going in and out of something like that. Anyone else? Well, thanks everyone for coming. Hopefully it was interesting, learned a couple things. Appreciate everyone coming by. Swing by our booth, 461. Be glad to run through the new panel offering with you, give you a walkthrough of that, and answer any questions you might have about how that can be implemented in your process. Thank you very much.